Okay, so DDL, data definition language. In this lesson, you will begin to work with DDL, data definition language. DDL is a SQL syntax that defines how tables are organized. So here you have your syntax: create table, alter table, drop table. What it does when you create a new table and define the columns and relationships. Change or update the structure of a table. Remove a table from the database. All data will be lost. So those are your syntax. Let's go talk about your create table. The create table command creates a new table in your database. So here you'll have your syntax: create table, table name, column name, data type, constraints, and so forth. Here you go to your Object Explorer, open up your database, and here you have your query and then your commands. So in the example above, we create a new table in the DB1 with ID, first name, last name, birthday, and job title columns. We must specify the data type of each column, such as an integer or varchar, a string up to 20 characters long. We can also specify constraints. Constraints are rules that only allow certain kinds of data to be stored in the columns and tell the database what can and cannot be done with the field. For example, the primary key constraints marks a column as a PK for the table and not null. Constraints does not allow a null value to be stored in the field. Whenever we create a table, the SQL files used to be created should be saved so that tables can be created again on another server if needed. The following constraints are commonly used in SQL. So you have your constraints: not null and unique. The purpose of not null is to ensure that column cannot have a null value. Unique ensures that the values on the column are different. You have your primary key, foreign key, default, and auto increment. So a primary key, a combination of a not null and unique, uniquely identifies each row in the table. Your foreign key uniquely identifies a row record in another table. Default sets a default value for a column when no value is specified. Auto increment: when a new record is added, auto increase the primary key. So primary and foreign key relationships. In SQL, we can build a relationship between tables through primary keys and foreign keys. A primary key, very important, on a table tells a database that this data is uniquely identifies a record. A primary key must be unique. It must be not null, and it can be made up of more than just one column. So in a very simple primary key setup, we might have a field called city ID. The ID is a number that never repeats and never null and uniquely identifies a record. There could be only one record with a city ID 1 in this example. So in a complex primary key setup, the key can be made up of multiple columns. For example, if we have a table called calendar with 3 columns: day, month, and year, the primary key could be made up of a combination of all 3 values. So we could have multiple records with a value of 2019, but only one record with the year 2019, a month of 4, and a day of 01. A foreign key creates a link between the 2 tables by pointing to the primary key in another table. In the previous address example, every address record in a city that identifies the city record and it relates to. There could be many different address records that share the same city. We call that a many to one relationships. The opposite way to look at the same relationship is one to many. Just reverse the direction you're looking at the data. One city can have many addresses. So the last example is many to many. We have a table called employee and a table called skills. One employee may have many skills and some employees may share the same skills. The skill record is not unique to just one employee. You have your alter table. Alter table allows to add new columns, remove columns, and add or remove constraints from a table. Add constraints. Add constraint allows to add a rule, a condition to a table or enforce the data integrity. Your drop table will completely delete the table and all the data in the table. However, if a drop table conflicts with a foreign key constraints in another table, the drop table request will not be allowed. Key terms: constraint, primary key, foreign key, one to many, many to one, and many to many. Download 10.1 code example and go ahead and test and study that out. Go ahead and read your w3schools.com. So here you have your not null, unique, primary key, foreign key, check, default index. Here you have your so here you have an exercise you could do. So write its correct SQL statements to create a new table called person. So you just probably put create table person. Okay, so let's talk about your 10.2 data. Database design. The database might be the most critical part of your web application. Having the well-designed database is critical for the long-term success on your application. In this lesson, we're going to look at what makes a different design database. To get started, we'll begin by looking at a bad design. Let's say your website takes order from a customer online. Let's look at what the complete order looks like. So here you have your order number, order date, customer name, customer phone, a lot of data right here, different items, how much quantity, cost each, total, order total, and so on. So our first thought it might be is to take everything we see here and put it on one big table called orders. It will look something like this. So here you have your order table. So again with Excel doesn't take that much data. We can immediately see some problems trying to put this data into one table. Notice the repeating columns: item 1, item 2, item 3, and quantity 1, 2, and 3. This is your first red flag that something's wrong. You should never have columns in a database that repeats the same information, and there should never be one or more value in a column. What happens if the customer wants to order a fourth item? This design only allows for 3 items per order. What if we want to add additional information about the customer, like an email address? All our order information makes perfect sense on paper, but stops making sense as soon as we try to put it on the table. So to start solving our problems and building a good design, we need to normalize our database. So normalization here. What is normalization? Let's go ahead and take a definition. Database normalization is a process of structuring a relational database in accordance with a series of so-called normal forms in order to reduce data redundancy and improve data integrity. A simple way to say this: data normalization breaks a large table into smaller tables and links them by relationships. The key idea is that our table should be about one thing and one thing only. Customers, items, and orders are all different things. They shouldn't be grouped together in a single table. To normalize, we are breaking this ugly table into smaller pieces. Our first clue about what table we need are the nouns. So one thing you will just notice that all tables in the database are like nouns, like address, customers, cities, items, order, employees, etc. So looking at our order, it looks like we're going to need some new tables. The first tables that stand out here are orders, customers, and items. Let's design them. So here you have your item, orders, and customers. Notice that the customer ID is pointed to the customer IDs inside the orders and to the customers. So far, so good. We designed 3 tables. The order tables has a relationship with the customer table based on the customer ID. This is great because now if we want to keep adding new data about our customers, we can do that and never impact the orders table. This is a many-to-one relationship. So one customers have many orders can belong to one customers. In our design, it makes sense that an order would never belong to 2 different customers. Again, here you'll have your foreign key, customer ID, and it's going to customer ID primary key. So know that FK means foreign key and PKs mean primary key. Okay, so our next big problem is that it makes sense to have an item table, but how do we link our items to order? Let's think about the relationships. One order can have many items, but one item can have many orders. So this is the many-to-many relationships. Anytime we need many-to-many relationship, this is a clue that we need to introduce a new table to our design, a table that might not seem obvious at first. We need a table that lists out the items that are part of this order. We can name this list anything we want. One possibility is order item, which is fine, but I'm going to go with the shopping cart. The choice is up to you. Okay, let's talk about very quick about the primary keys and foreign keys on the shopping cart. This is the part is easy. Order number is a foreign key that points to the orders table. Item ID is a foreign key that points to the items table. So lastly, our order item and item ID together make up the primary key. There will never be a row of shopping cart that duplicates the order numbers or item ID. Our data is normalized, and now we can sound like geeks and say that my database is normalized in the third normal form. So this is going to call the third normal form. The key takeaway from this lesson is that we normalize by breaking large sets of data up into small sets of data. Each table should be only describe one thing. The rules of the database normalization. Here you have your rules 1NF. One, every record in the table must be unique. Number 2, each column in the table must contain a single value. Number 3, no repeated columns, fruit, like such as fruit 1, fruit 2, fruit 3. Second rule, all the above plus every column must depend on the primary key. Third rule, all the above and. Number 3, no other columns in the table can depend on another column except the primary key. This is called transitive dependency. Example of a broken NF, so city tables. So here you have your city ID PK 5, and notice that here this is about cities, and here on the right it just has some random stuff like state tax rate and the height of Mount Everest. In the cities table, we have information about New York City. New York City's mayor is Bel de Blasio. And the city tax rate is 3.8%. The statewide tax rate is 8.82%. This piece of data doesn't depend on the New York City, and neither does the height of Mount Everest. Since the data doesn't depend on the city, it shouldn't be in the city's table. So here you have the corrected way of doing it. Now you have your state ID. Now your state ID pinpoints all the way to your state name and then state tax rate. This is the example of a database that breaks the third NF rule. So here you have your author's pet favorite treat, and it says catnip. But this right here, we have information about the author Thomas Jackson. He speaks English, 64 years old, and has a pet named Snowball. All right, his pet's favorite treat is catnip. This breaks the third NF because the favorite treat depends on the author's pet, not the author's directly. If we change the value of the author's pet, the favorite treat may change. So corrected here. Now you have a pet ID. This pet ID goes into the name Snowball and his favorite treat. So here, go ahead and remember the key terms: normalization, 3NF, 2NF, one-to-many relationships, many-to-many relationships, transitive dependencies. Go ahead and download 10.2 code examples. Read about some of these further explanations. Introduction to database normalization. Agile data. Go ahead and read about that. And go ahead and read about what is a key. Okay, so I want you guys to also check out the lab 10.3 lab. So in this lab, we'll walk through creating a database that tracks employees. We'll go step by step through the design and creation, create the database, create a new database called lab 10. Make sure you create a folder on your computer called DBS so that we can store the main file and the log file. So here, plan the tables. Our database will have 4 tables: an employee table for holding a list of employees, an employee status table for holding a list of employees' employment status, such as actively working on a vacation, a job table for holding a list of job titles, a department table for holding a list of departments. Next, let's plan out some possible columns for these tables and identify the primary keys. Finally, let's identify any foreign keys relationships. We want to connect the employees to their jobs, title, status, and departments, so the foreign keys might all look like this. Create the tables DDL and SSMS. Create the tables we identify using create table, alter table commands. Here, the first table to get you started. Populate some sample data. Use insert statements to populate the sample data provided below into the statements. Create a view called employee details that displays table information shown below, and that'll be your 10.3 lab. Let's talk about your 10.4 lab. Okay, continue to improve the lab 10 database by adding a salary table, being sure to include a primary key and a foreign key on the table. Populate the salary table with some sample data, and that'll be it for your 10.4 lab. Anybody have any questions? All right, so go ahead and get started working on your labs, all right?